All right, finishing this example, or again, if you've kind of lost your bearings, this is example 3 on day 134 and 135 notes. I just talked about how the square root of x to the 4 equals x squared. No absolute value bars needed. But I think we can kind of skip ahead to what the gist is of this. Look, this is following a very similar pattern here. Since x cubed comes out as an odd power, we actually have to absolute value bar it. Therefore, this fits the same pattern as the one originally given. Okay, so what you're going to do is, when it approaches positive infinity, you're going to divide by x cubed. And on the top, divide by root x to the 6. When it's the limit as x approaches negative infinity, in this particular situation, you're going to divide by x cubed negative or root x to the 6th power. So I don't know if I need to map that whole situation out for both of them for you. I'll do it. So divide by root x to the 6 on top. Divide by x cubed on the bottom. For the second part, divide by root x to the 6 on the top. Divide by negative x cubed on the bottom. So then looking ahead, those cancel. That's going to zero out. That's going to zero out. That's going to zero out. This cancels to become a constant. The limit as x approaches infinity is root 2 minus 0 minus 0, so root 2, over negative 7. For this next part, these cancel. These two zero out when you apply the limit as x approaches infinity. This zeroes out when you apply the limit as x approaches infinity. That negative on the bottom does not suddenly undo the zeroing property. But this negative divided by negative, that creates a positive 7 where these cancel. So it's root 2 over 7. Wow, that was really intense. Let's move on to some new stuff. All right, so what I'm going to do for you guys is give you two formulas, but I want you to understand where they come from. I'm going to try to get a better marker. All right. Let's say we have an asymptote A. So it can be anywhere. It can be left of the origin. It can be right of the origin. I'm just going to randomly say, here's my y-axis, here's my x-axis, here's A. Okay? So there's an asymptote right here. Now, if it has the property of 1 divided by x minus whatever my asymptote is, then it always follows this kind of pattern. And think about it, guys. If you plugged in, say you plugged in 0 for x, then you're left with 1 divided by negative a. You are left with a negative value. So what happens is, everything to the left of this is going to be squeezed below the x-axis. It's going to follow roughly this pattern, okay? And then everything to the right of this asymptote, so let's say it's like, I don't know, plug in 2a, which would be double this value, so it would be somewhere off over here. 2a minus a would be a. 1 divided by a, if we're saying a is a positive number, would be a positive value. It is always going to be above the x-axis. So hear me out, just in case you're completely confused right now. Let's just pretend like, oh yeah, there's one of those graphs I remember looking at and graphing back in the rational functions chapter. Graphing sense. We saw that back in January-ish. We are now talking about limits from the left and the right if you are not given the actual graph. And what you can do is you can actually say, if you are ever talking about the limit as x approaches a from the right, which here's a, from the right, we can always say that that limit is going to approach positive infinity. Okay, that's just the way that those asymptotic type functions work. And if it's approaching a from the left, and we've broken it down to look like 1 over x minus a from the left means it's going to be negative infinity. So how's that going to be helpful? Well, let me show you. So the first limit I have, all right, this is number 4 on the notes. I want to keep these in view, though, as I work through this. It's the limit as x approaches 5 from the left of 12 minus 3x divided by 25x minus x cubed. So here's what our goal is. Our goal is to actually rewrite this function as a product of 1 over x minus 5 and some other function. Okay? Let me repeat that. I'm trying to rewrite this as a product of 1 over x minus 5 times some product that would give me 12 minus 3x over 25x minus x cubed. Here's why. I can actually multiply limits together if I'm talking about taking one from the left and the right. That's a possibility here. Because what I can do then is compare this, which has a domain issue, right here. That's what the limit has always been when we've been talking about it without graphs, times something that does not have a domain issue at the spot we're trying to find the limit. If this question mark doesn't have a spot of domain issue, then I can multiply it an infinite value times a finite value. Let me show you how this shakes out. So maybe we're going to keep this in mind, but it's going to take a few steps to get there. So we're going to keep this in mind over here. When you see this expression here, you should be thinking, how do I make the bottom come out to be x minus 5? Because I am trying to approach 5 from the left, which means x minus 5 creates the asymptote. Well, I can factor the bottom, right? The bottom factor, here, let's just do some scratch work off to the side here. You can take out an x. You can also factor this by difference of squares. 25 minus x squared is the same as 5 minus x times 5 plus x. Furthermore, I'm looking for this. I want x minus 5, not 5 minus x. So what I can do is I can take the negative out of 5 minus x minus 5, and it creates a positive x and a negative 5 when I take that negative out. So here's the bottom of that rational function that I have. Negative x minus 5, 5 plus x. And this is what I'm allowed to do. I am allowed to say that this is 1 over x minus 5 times everything else compounded together. So I've basically said extract this part and rewrite it as a product over here. And now you've got 12 minus 3x over negative x times 5 plus x. And here's what that does for us. If you're approaching from the left of 1 over the asymptote, it's going to be negative infinity. That's just what the rule of the formula gives us because of how from the left it's going to, from the left it's going to negative infinity. So this right here is negative infinity from formula number 2. In the second part, you're just plugging in 5 because 5 is no longer a domain issue. So it's 12 minus 3 times 5. That'd be 12 minus 15, which is negative 3, over negative 5 times 5 plus 5. Okay, 5 plus 5 is 10. 10 times negative 5 is negative 50. So then, what's negative infinity times, we're going to go negative divided by negative is technically a positive here. Look, infinity is so strong that it doesn't matter whatever you multiply by. That infinity is being multiplied by some measly constant. That infinity is going to win every time. Okay? So negative infinity times 3 over 50. That's still going to be negative infinity. All right, so these just more sophisticated exercises in how can you manipulate mathematics, and this is super helpful if you ever get into any kind of math that requires higher level proof writing. Okay. All right, let's just keep rolling it on. Video number 3 coming up.